Hello everyone! We're going to look at some solve by factoring examples. So on this first example that we're going to look at, we see that we have a trinomial. And when I look at this, I say, okay, there's an x in every single term, so I know I can pull out a GCF of an x. So when I pull out a GCF, my x gets pulled out, and that means now my trinomial changes to x squared plus 10x, plus 24 equal to 0. Good, so now we have that GCF pulled out in front, and then we notice that trinomial, now we can do the product sum, or some of you may call it the AC method. Either way, we're still trying to find factors of 24, that C term, that adds to be that B term, which is 10. So hopefully you guys gather that that's 6 times 4 that multiply to be 24, but when you add them, they equal 10. When we look here, we notice the A term is 1. So since the A term is 1, we're able to go ahead and do the little shortcut method that you just open up your parentheses. Factors of x squared get put in front, so x and x. And then your two factors that you found over here get slotted right in there. So plus 6 plus 4. And don't forget to bring down this GCF out in front. That's a common mistake that we do often. We kick out that x in the beginning, but then we forget to drag them along through the equation. Now we should notice, set these equal to 0, we should notice that this is in completed factored form. So now that we're in factored form, we take each factor and set them equal to 0. We're really good at taking these ones and saying x plus 6 equals to 0. We solve for x, so we subtract our 6, and we get x equals negative 6. There's one answer. We do the same concept with the x plus 4, giving us x equals negative 4. There's our second answer. But we sometimes often forget to bring down this x that we pulled out and say, hey, x gets equal to 0, and that one's already solved for you. X is already by itself. So there's your third answer. And we know at most we can get 3 answers from the very beginning of this equation because this was a cubic function all along. Now we look at this example and we say, well, it's not quite set equal to 0, so I don't want to continue that yet. I want to first solve so it's set equal to 0. So x to the 4th minus 5x squared minus 6 equals 0. Good, so now that we have it equal to 0, I say there's a trinomial. I check if there's a GCF. There's nothing that I can do. So it's the same process as that we did on example 1 when we had an x squared out in front for our leading coefficient. Well, actually, 1's our leading coefficient for our A term. And we say, well, before we would find factors and we'd separate the factors of x squared got put right in the front slot of each parenthesis. That's why we would have x and x. Same concept with this one, but instead of x and x, we take the factors of x to the 4th and say x squared. Okay? Then we continue the same process, the factors of negative 6, that add to be negative 5, and you should get our negative 6 times positive 1, and those still add to be negative 5. So now that we found those factors, we slot those right in our parentheses. So negative 6 and positive 1. Good. We're in factored form. There's nothing else that we can do inside of each of these binomials, so we know that we take each factor and we set them equal to 0. So the first one is x squared minus 6 equals 0. Good. When I solve for x here, I get x squared equals 6. Then we notice that we don't want x squared as an answer. We want what x equals. So the opposite operation of squared is to square root. Square root, what you do to one side, you do to the other side. So then you see that the square root and the square go away, giving us x equals, anytime you physically write that radical, you need to remember to do plus or minus the square root of 6. There's 2 answers. I hope we all notice that we get 2 answers because we have a plus route and a minus route. So there's 2 of our answers. Do the same concept over here for the x squared plus 1 equals 0. Start solving for x. So move the 1 on over to the other side. Now, same thing, you square root. X equals plus or minus, well, let's look at this. Back when we were learning about imaginaries, we knew anytime we had a negative underneath a radical, you pull out an I. So there's my I. I remembered to do my plus or minus sign out in front. And this time, well, the square root of 1 is just 1. So either you can write 1i, or you can just say that's in simplest form right there. Notice, we knew at most we can get 4 answers again because this was a quartic function, at most 4, and we're getting plus or minus radical 6, there's 2, and plus or minus I, there's our other 2. So we got at most our 4 imaginary numbers. Good. Here's our next example. On this example, we see that we have 4 terms. Most of us are going to go straight into grouping, so I'm going to do what I think is going to be the most common thing that would happen. I know some of you may see that there's a GCF of x that we can pull out, but let's say we didn't notice that. We go ahead and we group our first 2 terms. We get x to the third comes out, leaving us x plus 2 inside. And then we do the same thing on over for these guys over here. The next 2, our GCF is negative 4x, giving us x plus 2. Remember, you have to have the exact same thing inside of our parentheses right here. Then we go ahead and write the numbers on the outside together in a binomial, giving us x to the third minus 4x. There's 1. And then the things that are the same inside of our parentheses get written once. Good. So right now we look at this and we say, okay, well, what can we do with this? I know immediately most of us are going to go ahead and get this answer and say x equals negative 2. Good. That's a good thing. But when I look at this example out in front, I say, well, what can I do with this? Then a lot of us are going to notice, oh, I have a GCF. Instead, because we didn't pull it out in the front like we talked about, we know that we can pull that GCF out now. So I'm going to say x can come out, giving me x squared minus 4. And then that's great, because you guys, we talked about earlier in the examples too, we knew that this x out in front needs to get set equal to 0, so x equals 0. There's another answer. A lot of us can do 2 routes with this thing. If it says completely factor, you have to completely factor x squared minus 4, because we should notice that is difference of squares. Okay, so we know we can open up our parentheses and say x plus 2 and x minus 2. Good. And then we get our other answers, x equals negative 2 and x equals positive 2. So there's our 4 answers. But notice that when I circle these, I notice that I get 2 answers that are exactly the same. And we just previously learned that if we have 2 of these, we're going to go ahead and say it's x equals negative 2 with a mult of 2, because there's 2 of them. Other answers are x equals positive 2 and x equals 0. I'm going to just go ahead and write them all together. Earlier, real quickly, when I talked about some of us have different methods to solving this. Some of us can go ahead and we would do x squared equals 4, and then x equals radical, plus or minus 2, and that's where you would have gotten the exact same answers. But you have to read the directions and be very careful. If it says you have to completely factor, then you must do that difference of squares. And I just went ahead and wrote my answers nice and clean over here, including my multiplicity of 2. Thank you.